Right, in this video I'm going to show you how we can use the chain rule in a slightly more simple way than the formal dy by dx is dy by du times du by dx. Let me give you an example. So if I give you example number 1, and we've got y equals 2x plus 1 to the power 7. And we're going to differentiate that. Well, this is known as a function of a function, and I've talked about this in a previous video on chain rule. It's the way that we normally spot chain rule methods. We've got a function of x, 2x plus 1 inside the bracket, and it's being acted on by a power function, power 7. So you have a power function, a function acting on another function of x. So it's known as a function of a function. Certainly, by all means, if you want to, you can go through the formal chain rule, working out u and du by dx and so on to get to the answer for dy by dx. But you can short circuit all that work by approaching it in the following way. And if you master this function of a function quick method, it makes chain rule questions really simple. So you can go straight to the answer. Dy by dx will be equal to, and this is what we say. You've got a function of x that's being acted on by a power 7 function. In this scenario, the power 7 acts upon the 2x plus 1. So the power 7 is said to be the priority function. And we deal with the power 7 first. And what we do is we just obey the rules of the power that we did in year 12 for differentiation with powers. In other words, the 7 goes to the front, the 2x plus 1 remains the same, and the power of the 7 turns into a power 6. So it goes down by 1. Now that has dealt with the power function. But we haven't yet finished to get the full answer. What you now need to do is go inside to the minor function, which is the 2x plus 1 inside the bracket. You differentiate it to get 2. 2 for that, nothing for that. And you multiply by that 2. And this simplifies then to 7 times 2 is 14 lots of 2x plus 1 to the power 6. And there's the answer. And if you went through the chain rule formally by letting u equals 2x plus 1 and working out dy by dx equals, and then applying the formal chain rule formula, as we've done in previous videos, ultimately you'd end up with that same answer. So let's do another similar sort of question to this. So y equals, how about 3x minus 2 to a power 5? And you've got to differentiate that. So straight to the answer, dy by dx will be equal to, it's function of x acted on by a power function 5. The power function takes priority. So deal with the 5 first. 5 to the front, power goes down by 1. You then multiply by, go inside the bracket for the minor function, 3x minus 2, differentiate, you get 3, and you multiply by that 3. And this gives you an answer of 5 times 3, 15 lots of 3x minus 2 to the 4. So it's really simple. Again, you could check that with the formal chain rule if you want to. Okay, so question number 3. Let's have a look at this. So y is equal to, how about something like this? A minus 2x to a power 10. Dy by dx this time will be, power function takes priority, 10 to the front, power goes down by 1. Multiplied by, differentiate inside the bracket, 8 becomes nothing, minus 2x is minus 2. So put this in a bracket because it's a negative, you multiply by minus 2. Simplify it, 10 times minus 2 is minus 20, lots of 8 minus 2x to the power 9. And there's the final answer. Now, sometimes these have all involved basic powers with algebra expressions. You might have something like this. You might have y equals sine of 3x to deal with. So this here is going to be a chain rule involving a standard derivative. But using this new quick method, it's really simple. You've got a 3x function and that is being acted on by a sine function. So it's sine of 3x. So it's function of a function. The sine takes priority, so you deal with the sine first. So to get dy by dx, you say, what do you get if you differentiate sine? Well, if you know your standard results, you know it's cos. So you get cos of the same angle. 3x, if that's 7x, that would be 7x. This is 3x, so that's 3x. So that's dealt with the sine differentiation, but you haven't finished. You now multiply the whole thing by, you go to the minor function, which is 3x, you differentiate 3x to get 3, so you times by 3. This is equal to, now do not make the mistake of saying cos of 9x, because you don't do 3x times 3 to give 9x. It's the whole of this that gets multiplied by 3, so we write this as 3 cos 3x. And there's the final answer for that one. Again, the same answer that you'd get as if you used the formal chain rule by letting u equals 3x, etc., and going through the whole process. Okay, so let's have a look at number 5. How about if I said to you, differentiate, let's say f of x is equal to cos of 3 minus 4x. And I've got to differentiate that. We can go straight to the answer f dash of x, and I can say straight away that I've got a cos function acting on a 3 minus 4x function, so it's function of a function. So the first thing that you do is the cos takes priority. You differentiate cos, you get minus sine of the same angle. You then go into the bracket and deal with the minor, the lesser of the functions, 3 minus 4x, and you differentiate that, and you'd get just minus 4. So you multiply the whole thing by minus 4. Equals. A minus times a minus is a plus. 4 goes to the front. Sine of 3 minus 4x. And there's your answer. Simple as that. Okay, a very simple process. Number 6, how about this one? Y is equal to e to the 2x. Okay, so dy by dx is equal to, straight to the answer, you've got a 2x function and it's being acted on by the exponential. The exponential takes priority. So exponential, differentiate it, you get the same exponential, so you get that. You then go to the 2x, you differentiate 2x, you get 2, and you multiply by that 2. Simplify this, and you end up with 2e to the 2x. As easy as that. Number 7. Let's do another exponential. Y equals e to the 5 minus 4x. Okay, so this is a slightly more complicated looking one, but it's really simple. Dy by dx will be equal to 5 minus 4x is being acted on by the exponential, function of a function. So exponential takes priority. Exponential function differentiator, you get exactly the same exponential. You then go to the 5 minus 4x, you differentiate that, you get negative 4. You multiply by that negative 4. So your final answer will be minus 4 lots of e to the 5 minus 4x. And that's the end of that question. Okay, number 8. Let's turn over. Let's have a look at number 8 here. Okay, how about this one? Y is equal to, how about e to the x squared? Okay, again, very simple. Dy by dx is equal to, x squared is being acted on by the exponential. Exponential takes priority, stays exactly the same. Multiplied by, differentiate the x squared, you get 2x, so you multiply by 2x. End up with 2x e to the x squared. And there's your final answer. Easy. Number 9, let's do one with logs in. I'll use the f of x notation for a change. How about log to base e of 3x plus 1? Got to differentiate that. Function of a function, 3x plus 1 is the basic function. Log function acts upon that. Function of a function. So to get f dash of x using the right notation, first of all, log takes priority. What does log do? It changes log of 3x plus 1 to 1 over the 3x plus 1. That's the first step. That's dealt with the log. And then you multiply by, and then you go inside the 3x plus 1, differentiate it, you get 3, and you multiply by that 3. This simplifies to 1 times 3 is 3 over 3x plus 1. And there's your final answer for this log. So, really, really simple. And all of these here have been very quick to get to the answer. In the next video, because I'm going to stop this video at this point, I will do function of a function on slightly harder algebraic ones, which require a little bit more care.